Okay, happy Thursday, everybody. Today we are going to continue talking about weather, and specifically now we're going to be looking at the frontal boundaries and what the weather conditions result in if two different air masses are interacting. So, for our notes today, you can continue using the foldable, which I have attached to today's lesson, or you can just type these down in your notebook, or you can just watch this video. So first, a front. The definition of a front is a boundary where the air masses meet, and these air masses don't mix. So if we have a polar air mass and a tropical air mass, right where they meet would be called a front. They're not just going to mix, they're going to interact in some way. Our pictures of different fronts are over here, and you can see that this is our cold front, and it's usually blue, and it has these kind of icicle-like arrows, and the direction the arrows are pointing in is the direction the front is moving. So this front, all of these fronts, warm and cold, would be moving this north direction. Warm front, you can see, are rounded, and then we have our stationary and occluded front. The weather is going to be dependent on the air masses colliding. You're going to get different weather if you have a tropical maritime air mass versus a polar continental air mass colliding. Based on which one is colliding with the other one will vary what weather we get. Here you can see this is a warm front. We know because it is red and it has these kind of softer curves, and it is moving in the northeast direction. So first, a question. When two air masses collide, the more dense air mass goes under the less dense air mass. That makes sense. Just like an object, if you're putting it into water, if it is more dense, it's going to sink. So if we have cold air mass, a polar air mass, hitting a warmer tropical air mass, which one is going to rise? Well, you might say the less dense air mass is going to rise, and we know that warm air is less dense than cold, so that warm air is going to rise. And that's exactly what happens on a cold front. So this is where a colder air mass, like a polar air mass, runs into a slower, warm, tropical air mass. That cold air slides under the warm air, and that warm air is suddenly pushed up. And when warm air is getting pushed up, and we know warm air can hold a lot of water vapor, can be very humid, and once that rises up, that air is cooling, condensing, forming clouds, and we get fast weather changes like thunderstorms, lightning. You get a lot of extreme weather if we have a cold front moving in, that cold air pushing up that warm air very rapidly. Okay. Our picture of our cold front, again, I think of them as little mini ice cubes or icicles, and the direction the cold front is pointing in, the arrows are pointing in, that's the direction the cold front is moving. Okay, you can see lower temperatures than where that warm front is. Once the front passes, though, we get clear skies, and depending in the summer, you still get cold fronts. It's not going to be as cold as a cold front in the winter, of course. And then since the skies are clear, it's going to get sunny, and that actually might heat things up pretty quick. Okay. In comparison, a warm front is where the warm air mass, the tropical air mass, is running into the slower, colder polar air mass. That warm air, because the cold air is more dense, it's going to stay towards the bottom. It's going to be kind of in this wedge shaped. It's going to be moving up slowly. Okay, here you can see our pictures. Warm, just think of these as like W's, moving in this direction. And for this, you might notice that a warm front is coming through if there's really high cirrus clouds, and you'll notice those before then you'll see more clouds once a warm front gets closer. So we get light rain with a warm front. Once the front passes, still might get some rain. It's more humid though and warm weather. Okay, so here you can see our different fronts. I have a quick video to show you guys.
fronts and warm fronts. These are weather systems that develop wherever masses of cold air collide with masses of warm air. And the name actually comes from war, where armies would meet along a battle line called a front. And one way to think about the difference between cold fronts and warm fronts is to think about which mass of air is going to win the battle. So we'll start with a cold front. This is a situation that happens where cold air moves in like a big wedge underneath warm air. Cold air is always heavier than warm air, and so it's denser, and it's going to tend to slide under the warm air and push the warm air upward. Anytime you have air rising upward, it's going to expand and cool and lose its ability to hold moisture, and this will give you a band of clouds and precipitation along a cold front. On weather maps, if you watch the weather on the news, you can see cold fronts marked by lines of blue teeth that point in the direction the cold air is moving. Along cold fronts, you typically have very intense local thunderstorms and rainstorms. So it might pour rain for a short time, but then quickly, usually within an hour or so, the front will have moved on. So a cold front is where the cold air pushes underneath the warm air, and you have high rainfall and usually intense thunderstorms. Now, the warm front has in common a couple of things with the cold front. One is that the warm air still goes up on top of the cold air, but in this case, the warm air is actually pushing the cold air out of the picture. So the warm air is winning, and that's how you can remember it. It's a warm front. The warm air pushes against the cold air, squeezing it out. Like imagine squeezing a watermelon seed between your fingers. It kind of squeezes out, right? And as the air pushes, it also rises up over the cold air. Rising air, again, loses its ability to hold moisture, and you tend to get clouds and rain. Along warm fronts, you typically have more mild, more mellow, more spread out rainstorms rather than really local intense thunderstorms. And if you're looking at the weather on the news, they mark warm fronts on maps with red half moons that point in the direction that the warm air is pushing the cold air. So that's cold fronts.
Okay. So there are two more types of fronts, as well as cold and warm front. One of them is a stationary front. So this is where a cold air mass and warm air mass collide, but neither displaces or moves one another. They're kind of stationary. They can't move. That's why you have like the cold front is trying to go south in this image. The warm front is trying to go north, and they don't really get anywhere. So what happens when you see this is that we get rain for a long period of time, or snow, or fog, or lots of cloudy days for many days at a time would be from a stationary front. Okay. The last front is the occluded front, so it's a little bit weird. So this is where warm air mass is caught between two colder air masses. That warm air mass is pushed up. So that cold air mass catching up with this other cold air mass, pushing that warm air up. So the temperatures often get quite cool because we have two cold air masses, and because the warm air is getting pushed up, anytime warm air moves up, we are going to be getting clouds. Here you can see it's going to be purple, and they are a mix of that blue and red, and it has the mix of the cold and the warm air symbols. Okay, so now just a couple quick practice. Take a look at the image, hold up your fingers in front of the screen, and I will give you about 5 seconds, and then I'll share the answer. So look at this picture. Is it 1 cold front, 2 warm front, 3 stationary, 4 occluded? If you said 1, good job. Next one. This is a stationary front, not going able to go anywhere. This one, hopefully you had 4 fingers up. This is an occluded front. This picture is showing number 2, a warm front. This is showing number 1, a cold front, cold air pushing that warm air up, getting those thunderstorms. We have cold front pushing the warm front up when that cold front meets another cold front. So this is an occluded front. Way you can remember that is we see occluded has C, C. So that's a cold front catching up to another cold front. That's a neat trick to remember that one. Okay, this is number 2, a warm front. We're going to see light rain, and you're going to see some cirrus and higher clouds when there's a warm front moving in. This is another stationary front. Okay, so today what you are going to do is there's a couple online activities I've put together for you. One of which is these Legends of Learning games. In order to find the Legend of Learning games, you go to your Clever page and you're going to click on this right here where it says Legends of Learning. It has LL. Once you click on that page, what you're going to do is, I have the teacher version, so it's going to look a little bit different for you, but you're going to be prompted to type in a teacher code. And the teacher code is Lang S4, and you're going to find the assignment 5-3 Storm Chasers. Another way to do this is if you just put in your search bar, log in legendsoflearning.com. Then you click Students Play Now and Play Teacher Playlist. And then you're going to put in that same code that I have on the instructions, which is Lang S4, and you'll be able to play the different games. Okay, that is it for today. Hope you guys have a good rest of your day, and I'll talk to you